Today we're going to examine the standard that requires our students to complete the square in a quadratic expression to reveal the maximum or minimum value of the function defined by the expression. So our students are going to have to do three things in order to master this standard. First, they're going to have to complete the square in a quadratic expression. Second, they're going to have to change a quadratic expression from standard form to vertex form. Third, they're going to have to recognize that the vertex hk is the maximum or minimum value of the quadratic function depending on whether a is positive or negative. Let's start breaking apart this standard by heading over to GeorgiaStandards.Org and looking at some great resources to help our students. Alright, now we're at GeorgiaStandards.Org looking for these resources. The first skill that our students are going to have to master is completing the square in a quadratic expression. So I went to Algebra 1, I went to Unit 3, and on page 73 is the completing the square and deriving the quadratic formula spotlight task. This task is wonderful for teaching our students how to complete the square when a is equal to 1 and when a isn't equal to 1. It aligns with our standards and those standards for mathematical practice as well. I had great success with this task in partners, and the time needed is 90 minutes, but you can adjust that as you see fit. On page 85 is our standard to vertex form spotlight task. This task is great for meeting the other two requisite skills required by our students, that is, changing a quadratic expression from standard to vertex form and knowing that the vertex hk is the max or minimum of the quadratic. This task also aligns with our standard and our standards for mathematical practice. I had good success in implementing this task in partner pairs, but you can do it any way you like, and a good estimate of time was given for this task at 60 minutes. Here are two of my students working together on the standard to vertex form spotlight task. In the task, they will learn to identify key features of the quadratic function by completing the square. In order to satisfy our standard in question, the students will first have to complete the square in the quadratic expression. Students will not only master the academic standard in question, they will also master the standards for mathematical practice, which are aligned in the task. The one in particular I looked for was to look for and make use of structure by expecting students to apply rules, look for patterns, and analyze structure.
So, 10 over 2 squared is b over 2 squared, and b is 10, so you got 10 over 2 squared. X squared plus 10x plus 27, and then plus 25, right? No. You have to put plus 25, plus 25, and then put that in the parentheses, square, and then plus 27, and then we gotta do the inverse and minus 25.
I don't think you're supposed to square it.
You don't think
Are you?
No, maybe not. Yeah. Maybe we're not supposed to square it yet.
After students have successfully completed the square, students will need to change the expression into vertex form.
We can multiply to get 25 and plus 5. So we got x plus 5 and x plus 5. So it'd be just x plus 5 squared and then plus 2.
Students may use a graphing calculator or Desmos calculator on the computer to make the connection between the vertex and the minimum and maximum.
You could find the vertex using the formula y equals x minus h squared plus k, where the k is the y value, and then the negative h would be the x value. And it's at, the vertex is at point negative 5, positive 2.
And this point is the minimum because that's the minimum of where it goes.
It's the lowest point on the
Yeah.
graph. There's no reflection on the equation. If there was a reflection, there'd be a negative sign in before the parentheses, and that would make the graph pointing downwards and then the vertex would be the maximum, so the graph would go down to negative infinity.
Sometimes our students are more able to explain concepts to their peers than we can as their teacher. This last clip shows a student explaining a way to determine the vertex just by looking at the vertex form.
Well, you take the number that's in the parentheses and whatever sign it has in front of it, the horizontal shift will be the opposite sign. So this is +5, so it'd be -5.
Okay.
And on the outside, which is a vertical shift, it's whatever sign it has. It's +2, so it'd be a +2 vertical.
Look at what the sign is for A. If the sign is if A is negative, it would be a maximum, and if it was positive, it would be a minimum. Like this is a minimum because it's positive.